If you make food, especially anything processed, there's a real chance your product either contains nitrosamines or could form them under the right conditions. This isn't a scare tactic, it's chemistry. And regulators are starting to expect that you understand it and that you're testing for it. The good news? This is testable. You can screen for it, you can measure it, and we're going to show you how. This kind of testing is already common in other industries. Nitrosamines have been on the radar in pharmaceuticals for years, and more recently, cosmetics. Now, the focus is shifting to food. And it's not just bacon and beer, they're showing up in everything from spices and soy sauce to baby food. If you handle food safety or quality, nitrosamines are something you can't ignore. In this video, we're going to talk about what nitrosamines are, how they get into food, why regulators care, and how you can test for them. We'll show you what tools are available and how they fit into a real-world workflow. If this sounds useful, give the video a quick like. It helps other people in the industry find it. And if you want more content like this, hit subscribe. But let's start with the basics. What nitrosamines actually are and how they form. Nitrosamines are a group of chemical compounds that can form when nitrites or nitrates react with amines, nitrogen-containing compounds that are found in proteins and protein breakdown products. The chemistry behind it is pretty straightforward. Nitrites, often used as a preservative in cured meats, convert into nitrosating agents under acidic or heated conditions. These agents then react with the amines to form a nitrosamine. It's not a single-step reaction though. There are different pathways depending on the food matrix, the pH, and temperature, but the key idea is that the building blocks are already present in many foods. This reaction becomes even more likely during curing, frying, fermentation, or long-term storage. Even mild heating like pasteurization or drying can create the right environment. You'll come across nitrosamines like NDMA, NDEA, NPIP, NMOR, and NDBA. Each one has a slightly different structure depending on the amine that it came from, but they all come from the same core process, nitrization of an amine. NDMA and NDEA are the most studied. Both are classed as probable human carcinogens, and they've been found in pharmaceuticals, cosmetics, and now a growing list of food products. Others like NPIP and NMOR, they're less well understood, but they're monitored due to structural similarities. The key challenge here though is quantity. These compounds form at nanogram levels, far below what you'd ever see or taste. But regulators are increasingly focused on them because they're biologically active, even at these trace levels. So how does this play out in real-world production? Nitrosamines don't usually form from raw ingredients, they form during processing. Anytime you mix nitrates or nitrites with protein-rich ingredients, apply heat, give it time, there's potential for formation. They show up most often in things like cured and smoked meats, beers and spirits, fermented sauces and seasonings, cheese, baby food made with nitrate-rich veg. Even natural products aren't immune. If the chemistry is right, nitrosamines can form, whether you meant it or not. The concern with nitrosamines isn't new, but the focus on food is intensifying. In October 2023, the European Commission adopted Regulation 2023/2108. This amended previous regulations and reduced the level of permissible levels of nitrates and nitrates that are used as food additives. This move aims to minimize the formation of nitrosamines during food processing and storage. Denmark has implemented even more stringent national provisions, maintaining lower maximum levels of nitrites for certain meat products compared to the EU standards. In France, health authorities have confirmed the link between nitrates in processed meat and an increased risk of colon cancer. This has led to the recommendations for reducing nitrate use in meat processing. While the United States has established acceptable intake limits for nitrosamines in pharmaceuticals, similar regulations for food products is under consideration. If you export food, you can expect regulators to ask for test data. And even if you only sell locally, questions from retailers or the media can put you under pressure. Nitrosamines in your products don't necessarily mean that it's unsafe, but if you don't know they're there or you haven't tested for them, that's where the problems start. And that's where testing comes in. There are two different ways to approach nitrosamine testing. The first is screening. This is where you look for the total nitrosamine activity using ATNC, or the apparent total nitrosamine content. It won't tell you exactly which compounds are present, but it gives you a clear signal. Is there a nitrosamine problem here? Yes or no? The second is targeted analysis. This is where gas chromatography comes in. Typically a GC with a nitrosamine-specific detector, such as the Ellutia TEA. This method separates out specific compounds like NDMA and NDEA, and it tells you exactly how much of each there is. In most cases, you'd start with screening. It's quick, it's cost-effective, and it helps you decide whether further testing is needed. If you get a positive or even a borderline result, that's where targeted analysis comes in. You can confirm exactly what's there and in what amount. Together, these methods give you both a broad view and precise detail, so you can monitor your products properly without over-testing each batch. At Ellutia, we offer tools for both stages of testing. We have the ATNC system, which is built for screening. It gives you a fast and simple way to check for total nitrosamines. And then we have the 200 series GC, which when paired with the TEA, handles the detailed work, identifying specific compounds and measuring exactly how much is present. Both systems are compact and easy to use, whether you're running tests in-house or working with a lab. But this isn't about overhauling your process. It's about knowing what's happening in your product and being able to prove it. So you start with screening. If something shows up, dig deeper. But either way, having the data puts you in control. If you got questions about how this testing works or what it would look like in your setup, there's more information in the description. We'll cover more on method development and in-house testing setups in future videos. But if this was useful, please give the video a like and subscribe for more videos like it. Thanks for watching.